All right, this is Geometry, Chapter 1, Section 8, Perimeter, Circumference, and Area. Our learning objectives are to find the perimeter or circumference of basic shapes and to find the area of basic shapes. Perimeter and area are two different ways of measuring geometric figures. The perimeter of a polygon is the sum of the lengths of its sides. The area, A, of a polygon is the number of square units it encloses. For figures such as squares, rectangles, and circles, you can use formulas for perimeter or circumference if it's a circle and the area. So here are these formulas, and make sure you write these down because these kind of don't go away. All right, so for a square, the perimeter is 4 times the side because you have 4 equal sides, and the area is the side squared. For a triangle, you take all of your sides and add them together, and then for the area, you just take the base and the height, multiply them together and divide it by 2, or multiply it by 1/2, either way. For a rectangle, the perimeter is 2 times the base plus 2 times the height, and the area is the base times height. And for a circle, the circumference is pi times its diameter. The diameter is all the way across. Or it's 2 times pi times the radius. The radius is halfway across your circle. The area for the formula is pi times radius squared. All right, we're going to use these formulas to find perimeter, circumference, and area. So let's take a picture of what that's going to look like. Here's our picture. The Botany Club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? Step number 1, find the dimensions of the garden, including the path. For a rectangle, length and width are sometimes used in place of base and height. So the width of the garden path is 4 plus 16 plus 4, which is 24. The length of the garden and path are 4 plus 22 plus 4, which is 30. So now the perimeter of the entire garden is 2 times base plus 2 times the width, and that's 48 plus 60. You add them together, it's 108. So you need 108 feet of edging material to go all the way around. All right, so let's look at our sample problem. We want to buy a picture frame that is 5 inches by 7 inches with a 1-inch wide frame. So let's make that happen. And all right, so now you know that from here to here is 1 inch. We know that the picture is 5, so from here to here is 5. Oh, I guess it would be the opposite. So this is 7, the long side is 7. And the short side will be 5. Okay, what is the perimeter of the picture? So we're going to take each of our dimensions and add 1 inch plus 1 inch to them. So my length is going to be 7 plus 1 plus 1. So that's a total of 9, and our width is going to be 5 plus 1 plus 1, which is 7. So the perimeter is going to be, because it's a rectangle, it's going to be 2 times the length plus 2 times the width. That gives me 18 plus 14, or 32 inches. Oh, okay, so that's the perimeter of the outside edge. The perimeter of the picture, which we'll do now, is 2 times 5 plus 2 times 7, which is 10 plus 14, which is 24. So one of them, the perimeter of the picture is 24 inches, and the perimeter of the frame is 32 inches. So that's it. All right, circumference. So the circumference is like the circle's perimeter. It's how far it takes to go all the way around a circle. We use pi times the diameter, and if we want the exact answer, we keep pi next to the 15. If we want the approximate answer, we can use the pi key on our calculator. This, for us, it's right here. Pi times 15 is 14.12. So for when we just have the radius, which is 4, you go 2 times pi times radius, 2 times pi times 4, 2 times 4 is 8, and then 8 times pi is 25.13. All right, so let's do this problem together. What is the circumference of a circle with a radius of 24 meters in terms of pi? So we're leaving pi in the answer. So the radius, so the circumference with the radius is 2 pi r, and in our case, that would be 2 pi times 24. We're going to leave pi in our answer, so we're just going to combine together the 2 and the 24 to get 48 pi. What is the circumference of a circle with diameter 24 to the nearest tenth? So now we have a different problem with where we have a diameter. So C is equal to, circumference is equal to pi times diameter. So that's pi times 24. And it wants the exact answer. Hold on. So we're going to go pi times 24. 75.4 meters. Thank you very much. All right. Problem 3, finding perimeter in the coordinate plane. So now I have coordinates. I learned the distance formula, so I can find the length of each side. So if I look here, I got G, F, and E. The distance between E and F is 6 minus -2, which is 8. The difference between F and G is 3 minus -3, which is 6. And then the distance between E and G, we have to use the distance formula, we find is 10. So we're going to add all those lengths together, 8, 6, and 10, to find out that the perimeter is 24. All right, so let's do that for this problem. Graph the quadrilateral JKLM with vertices -3, -3, 1, -3, 1, 4, and -3, 1. What is the perimeter of JKLM? The first thing I'm going to do is find a picture of a graph. So you guys can go scramble your graphing paper. Get out your graphing paper because I'm terrible at drawing straight lines. So I need the graph to keep my lines straight. Alright, so here's my graph paper. I'm going to plot my points. I'm going to make J blue, so he's at -3, -3. I'm going to make K green, and he's at 1, -3. I'm going to make L red, he's at 1, 4. And M is at -3, 1. Alright, so let's draw a straight line between each one of those. The ones I can figure out without too much trouble, I am. So let's do this. JK is 1, 2, 3, 4, 4 units. KL is 1, 2, 3, 4, 5, 6, 7 units, and then this is M, I forgot to put it on there, is 1, 2, 3, 4. So the one I have to use the distance formula is ML. So this one and this one. So I'm going to go square root ML equals square root of -3 minus 1 squared plus 1 minus 4 squared. That's equal to -4 squared plus -3 squared, which is equal to 16 plus 9, which is equal to 25, which is equal to 5. Phew. So let's find the perimeter. 4 plus 7 plus 5 is 4 plus 4 is 8, plus 7 is 15, plus 5 is 20 units. Perimeter. Whew, that was hard. Alright, now that we've done perimeter, let's do area. We got this. You want to make a rectangular banner similar to the one on the right. Boop. The banner shown is 2.5 feet wide and 5 feet tall. 2.5, 5. Convert the dimensions of the banners to yards. See, because it says to the nearest square yards, how much material do you need? So we're going to convert it to yards by multiplying it by 1/3. And then we're going to multiply base times height. Boom, boom. And make it into a mixed fraction so that we know it's not a weird improper fraction. All right, let's do a similar problem. We're designing a poster that will be 3 yards wide and 8 feet high. Awesome, let's have a picture. 3 yards and 8 feet. How much paper do you need to make the poster? So that's the area. Unfortunately, we need to fix our units. 3 yards. There are 3 feet in each yard. So we're going to multiply the 3 by 3 feet per yard to get 9 feet total. So the area is 8 times 9. or 72 square feet. All right, thank you, rectangles. Oops, wrong way. All right, area of a circle. Remember, it is pi times radius squared. So we always want to make sure you have the radius. And it's just the diameter cut in half. So in this case, it's 8 squared times pi, 64 times pi. And it's asking in terms of pi. So we leave the pi in the answer. Let's do that for this problem. What is the area of a circle in terms of pi? So the area is pi r squared. The diameter is 14, so the radius has to be 7. It's half of it. That's pi times 7 squared, or 49 pi. What is the area of the circle used in approximation of pi? Let's use 3.14 to approximate pi. So 3.14 times 49 equals 153.86. This is a decimal point. Which approximation of pi did you use in part B? We used 3.14 because it's quick to type. It's quick. To type. All right, area addition postulate says the area of a region is a sum of the areas of its non-overlapping parts. Essentially what it allows you to do is break your area up into different parts and add those areas together. So let's look at a little section here. This is 4. This has to also be 4. This is also 4. I'm going to cut this little piece off here because this is 4 feet. So from here, this dashed line has to be 12 minus 4, which is 8 feet. So I'm going to find the area of this rectangle here and add it to the area of this triangle. So let's go, the area of the rectangle is 4 times 12, or 48 feet squared. And the area of the triangle is 1/2 the base, which is, I'm going to say 4 times the height, which is 8. 4 times 8 is 32. Half of 32 is 16. And then the area addition postulate says we can add these two together, 48 and 16. Thankfully, the answer is in square feet. And it's 64 square feet.